Good morning, students. We are learning water resource engineering and hydrology, and the topic of discussion that is the hydrological parameters. Previously, we have discussed about a hydrological cycle, wherein we have discussed on various procedures or various processes that happens in that hydrological cycle, and that is evaporation, transpiration, precipitation, and infiltration. In today's lecture, we will discuss about one of that process, that is evaporation. Well, evaporation. For evaporation, we can say it is the process by which water changes from a liquid state to a gas or the vapor state. Okay, evaporation is the primary pathway that water moves from liquid state back into the water cycle as the atmospheric water vapor. Studies have shown that the ocean, seas, lakes, and rivers provide nearly 90% of the moisture in the atmosphere via evaporation. Okay, with the remaining 10% that being contributed by transpiration process that we will discuss in the next lecture. Okay, well, a very small amount of water vapor enters the atmosphere through the sublimation. Is the process by which the water changes from solid, that is in the ice or the snow form, to the gaseous form by passing the liquid phase. Now, this often happens in the Rocky Mountains as dry and warm Chinook winds. Well, when the dry air hits the snow, it changes the snow directly into the water vapor by passing the liquid phase. This is the sublimation that we have discussed. Okay, now this sublimation is a common way for the snow to disappear quickly in the arid climax. So to continue the evaporation, three basic conditions should be satisfied. First, that is there should be a constant supply of water. Second is there should be a constant supply of heat. And the last third one is there should be a vapor deficit. If we discuss that why evaporation occurs, so we all know that heat is necessary for the evaporation to occur. Well, energy is used to break the bonds that hold water molecules together. Now, which is why water easily evaporates at the boiling point, but evaporates much more slowly at its freezing points. Net evaporation occurs when the rate of evaporation exceeds the rate of condensation. Okay, now a state of saturation exists when these two process rates are equal. So there should be an equal rate of condensation and that should be an equal rate of getting evaporated. Okay, now at the point relative humidity of the air is about 100%. Condensation, that is the opposite of evaporation, occurs when saturated air is cooled below the dew points, that is the temperature at which the air must be cooled at a constant pressure. Now, in fact, the process of evaporation removes heat from the environment, which is why water evaporating from your skin cools you. How this evaporation cycle drives? Okay, so evaporation from the ocean is the primary mechanism supporting the surface to the atmosphere portion of the water cycle, as shown in this figure. Here is the ocean, that is the water surface we can say, and the water is getting evaporated in the atmosphere. Okay, now after all the large surface area of the ocean, it provides the opportunity for the large scale of evaporation to be occurred. Now, on a global scale, the amount of water evaporating is about the same as the amount of water that is delivered to the earth as a precipitation. So this does vary geographically. Evaporation is more prevalent over the oceans than the precipitation, while over the land, precipitation routinely exceeds the evaporation, and it should be, so that we can maintain the water level on the earth. Okay. Now, most of the water that evaporates from the ocean falls back into the ocean as a precipitation. Only about the 10% of the water is evaporated from the ocean is transported over the land and falls as the precipitation. Well, once evaporated, a water molecules spends about 10 days in the air, and if the process of evaporation is so great, that means in a so excessive manner, without any precipitation or the runoff or the groundwater discharge from aquifer or ocean, then it would become nearly empty on the earth. Okay, so this cycle should be run equally, so that it is mandatory that this cycles runs in a proper manner. Now next, let's discuss that what are the factors that affect the evaporation or the rate of evaporation. So we can say the rate of evaporation depends on few factors, and those factors are, first one, that is the temperature of air. Well, the evaporation increases with an increase in the temperature, and thus in the summer season we observe that in the hot countries the evaporation will be more as compared to that in the winter season or in the cold countries, we can say. Well, the next is the wind velocity. The process of evaporation also depends upon the prevailing turbulence in the air. If the velocity of air is more, saturated film of air containing the water vapor will move easily, and that causing more evaporation. Next factor, that is the atmospheric pressure. Well, a decrease in the atmospheric pressure always increase the rate of evaporation. It's because there are fewer molecules in the air above the free surface to cause the interference. Consequently, the evaporation is more at a high altitudes. Now the fourth one, that is the nature of evaporating surface. Well, different evaporating surfaces like soil, barren land, forest area, different houses, lakes, all this affect the evaporation to the extent that they have the individual potential. Well, on the black cotton soil, it helps to evaporate the soil water faster than a red soil. So because such soil have the potential to absorb the incoming radiation more effectively, such soils can have more evaporation. Evaporation from wet soil is faster, and it reduces gradually as the soil becomes drier. The evaporation from a snow surface is less as compared to that from a water surface. Moreover, the evaporation from snow take place only when the dew point is below the 0 degree Celsius. While talking about the area of water surface, the amount of evaporation is directly proportional to the area of evaporation. So if the exposed area is large, the evaporation will be more, and it should be vice versa. Well, the next factor, that is the depth of water body. Well, the depth of water influences the evaporation considerably. Deep water bodies evaporate slower than the shallow water bodies in the summer, while in the winter season they evaporate faster. The next factor, that is the humidity. If humidity of the atmosphere is more, the evaporation will be less, and if humidity is less, the evaporation will be more. Well, any dissolved salt in the water reduces the saturated vapor pressure of the water, which consequently reduce the rate of evaporation. The evaporation decreases by 1% for every 1% increase in the salinity of a water body. The turbidity of water may also affect the rate of evaporation by affecting the heat transfer within the depth of the water body. So these all are the factors that affect the evaporation as well as the rate of evaporation. Okay, next, that is the measurement of evaporation. So we have one method, that is the pan measurement method for measuring the evaporation. Well, it is the most reliable method for the estimation of evaporation large water bodies is that measurements from evaporation pans. Here, the depth of water that is evaporated from the pan of a given area and in a given time is measured with the help of a micrometer. So after that, the rate of evaporation is so obtained that it is multiplied by a suitable pan coefficient so as to obtain the evaporation rate from the given water body. So for that, here we have pan coefficient formula, that is the ratio of lake evaporation and the pan evaporation. In India, there are about 200 pan evaporimeter stations maintained by IMD, so that we can easily get the rate of evaporation at each and every year. Okay, so next is using empirical formula. Here we have the first formula, that is the Mayer formula. For that we have an equation, E is equals to m es minus a 1 plus v9 upon 60. This method we just have to mug up this formula, and by finding all these things we can find out the rate of evaporation. Okay, wherein es is the saturation vapor pressure at the water surface temperature, a is the actual vapor pressure at 9 meter above the water surface, wherein v9 is the mean wind speed at 9 meter above the ground level. Now km is the coefficient, that is we can take 0.36 for the large deep water and 0.50 for small shallow water. Well, the second, that is the Rover's formula. Okay, so this is the Rover's formula, and these are the notation, where again es is the saturation vapor pressure, ea is equal to actual vapor pressure, the new term, that is pa, that is mean atmospheric pressure, and v 0.6, this is mean wind velocity, that is in kilometer per hour. The next empirical formula, that is Lake Hafner's formula. Here V8 is the wind velocity at 8 meter above the water surface. Okay, this is the formula. By this we can find out the evaporation rate. So whichever parameter that we have, from that parameter we can find the evaporation rate. So by using this empirical formula, one parameter that you have to measure and apply it in these equations, you will get the values. Next method, that is the water budget method. This method balances all the incoming and outgoing and stored water in lake or a reservoir over a period of time. by using a equation, that is the E plus Qi plus or minus Qu is equals to E plus Qo plus or minus delta Qs. This is the balance of incoming and outgoing water, or we can say also the stored water. So let's see what is P. P is the total precipitation, Qi is the total surface inflow. Same way Qo is the surface outflow. Okay, Qu, that is the total underground inflow, or we can say the outflow, where the delta Qs, that is the total change in the storage, and E is the evaporation from the water surface. Next method, that is the energy budget method. Well, here this method is based on the principle of conservation of heat energy and the cooling that produced by evaporation. Thus, the energy available for the evaporation is determined by considering the incoming energy, stored energy, and outgoing from a water body over a known period of time. Well, net incoming energy would be Hn is equals to Hc to 1 minus R minus Hp, where Hv is the back radiation from the water, and the another term, that is Hc into 1 minus R, is the incoming solar radiation into the surface. Here each and everything is mentioned in this figure, that this is 1 minus R into Hc. This is the incoming solar energy. Okay, here is the Hv, that is the back radiation. Well, let's see the next term, that is the outgoing energy. Outgoing energy is equals to Ha plus Hg plus Hi. Okay, here Ha is the sensible heat loss to the air, which is mentioned over here. Hg is equals to heat loss to the ground. Here is the ground, so Hg is the heat flux into the ground. Okay, and the last one, that is Hi, net heat that is conducted out of the system by the water flow, that is here mentioned as a advection. Okay, this is the net heat conduction or heat conducted out of the system by water flow. Okay, so the third, that is the heat stored in the water body, that is Hs, mentioned over here. Okay, the next is heat used for the evaporation, that is He is equals to rho into La into E, where the rho is the density of water, E is the evaporation in millimeter, and La is the latent heat of evaporization of water. Okay, so after that, the total evaporation for the long period, that is Hn minus Hg minus Hi minus Hs upon rho into La 1 plus beta. We're talking about the short period. We can neglect the Hi and Hs. So the evaporation would be Hn minus Hg upon rho into La 1 plus beta. As here we are talking about the small period, we can neglect the Hs because it is the heat stored in the water. For the small, if we're talking about the small period, there is very rare possibility of storing heat into the water body. So that's why we are neglecting Hs, and same way Hi. Thank you so much, students, for your kind attention. I hope you understand each and every topic of this lecture. I will see you in the next lecture. Thank you.